Welcome to the Airlock IAM 8.1 release video. I'm Mark Bütikofer, Head of Innovation for Airlock, and with me is Michael Dujak, Product Manager of Airlock IAM. I'm going to present you the new features in IAM 8.1 and will give you a short overview of what is to come in this video. First, we start with the new IAM State Externalization feature, followed by OpenID Connect scopes and claims features. Then Michael will present Microgateway 4 support in IAM 8.1, followed by new FIDO self-services. And he will also present the new features regarding SSI. I will close the video with various smaller features and some general release information. IAM State Externalization. IAM State Externalization is a completely new feature in Airlock IAM, and in order to explain what it does and what the value is, I want to start with the current situation with a traditional IAM that was used before this new feature to show you what we have added in 8.1. So traditionally, if you have multiple IAM instances, traditionally you put them behind an Airlock gateway, which can do session sticky load balancing. Session sticky load balancing is required because Airlock IAM stores the session information locally in memory. So in the diagram on the left side, you see session A in red is stored in memory in the left Airlock IAM instance, and session B, for example, the green one, is stored in session B on the right side in memory. So every request to session A needs to go the left way, and every request on session B needs to go the right way, because the left IAM does know nothing about the session data in the right IAM. So what this means is, although we have some features like session tickets, inside a session you don't really have high availability. If one IAM goes down, session information is basically lost. And this may lead to session loss in failure cases or in upgrade cases and so on. It also prevents effective dynamic horizontal scaling, because you cannot just add new IAM instances and migrate the sessions from one to another IAM. So what we've done in 8.1 will be on the next slide, but one thing is clear: it still works the same as worked before. It still works. You don't have to do anything if you don't want to change anything. So what did we add in Airlock IAM 8.1? We added the possibility to store session information in an external Redis setup. So IAM does no longer store the session information locally, but stores it in a Redis setup, which is outside of Airlock IAM. So this means now any request can go to any IAM and it will just work. It doesn't matter if the first request of a session goes to the left IAM and the next to the right one, and so on. And it also means that you can do real active-active setups. So you have now, even across sessions, you have multiple active IAMs working together. So this also allows for horizontal scaling. You can add more IAM instances if you need it to scale up, and you can use less if you don't have a lot load. It also works, therefore, with, for example, an ingress controller of Kubernetes, or with another load balancer that has no concept of session stickiness. It also forms the basis for future upgrades at runtime. Saying this, I also want to emphasize there is no upgrade at runtime feature yet there, so it's still to come, but this is the basis for future upgrades at runtime. We'll keep you informed in the next release information video about the state of upgrades at runtime. So what it also makes possible, these features, you can use in a limited way. You can also use IAM without Airlock Gateway, but just with Airlock Microgateway. That's the small green boxes with Airlock Microgateway 4.0. And you will see more of that in Michael's part a little bit later. So what is really supported in these externalization features? So because it's not yet done, we have supported a few features, a lot of features, but not all of them, and it must be made very clear what is supported and what is not supported. So most of the login up is supported, but not everything. I will show you what's missing, and most of the admin up features are supported. That's basically it. So what is not supported? In the login app, we do not support SAML, but it is planned for 8.2. When I say planned, it's still a plan. So if you rely on this, just verify that's really in 8.2. We do not support Radius OTP authentication in the login app. This means connecting to a Radius server and verifying an OTP is not supported together with state externalization. Sorry. We do not support the bulk changes feature in the admin app. We do not support the config editor. So the idea is that you configure the IAM in a standalone or in a traditional setup and then use the configuration in a active setup or within a Kubernetes cluster and so on. Transaction approval is also not yet available, but this will be part of 8.2. And also the API policy service is not yet part of the stateless feature, but it may work to a great extent without doing anything. Then also not part of this feature is the service container. The service container is thought to run only once and keep it running and not in an active setup. What is also missing is data encryption. So the session data is stored unencrypted in the Redis system. So you have to take extra care that you protect access to this Redis system, because session information is very critical and very sensitive information. It is planned for 8.2 that we can encrypt the data in the Redis, so you don't have to care about this. Please consult the documentation for more detailed information about, for example, how to securely access Redis, so this is not a problem for setups with IAM 8.1. How to configure it? It's very easy. As said, if you don't do anything, it just works the old way without external state. If you want to store state externally, you have to set up a Redis system, and you can configure the state repository in the main settings, or if you don't use main settings, you have to reference it in every module like the login app and the admin app. Within this configuration, you basically just specify where the Redis system is running on what port. You need a user password, and very important, because of the missing encryption feature, you have to configure a trust store and a key store so nobody else can access your Redis account, so to say, and can also not listen into the traffic where session data is exchanged. So what's ahead? What are we going to do in the next release? What is planned? I already mentioned it before in the red part of the feature and missing feature slide. So again, it's transaction approval support. That's pretty sure for 8.2. Then SAML support, it's planned, but we don't know yet whether it's going to be in 8.2 or 8.3. Session data protection is there for sure. And also first features to support upgrades at runtime will be part of 8.2. The OIDC scopes and claims flexibilization feature is actually a bunch of features making OpenID Connect scope and claims handling a lot more flexible. To understand what it does, just first have a look of what we're doing now in IAM and what scopes and claims are all about. So assume we have an OpenID Connect reline party or client, and we have an OpenID Connect server or provider. in this case, this is Airlock IAM. It's the role of Airlock IAM. Then when a OpenID Connect relying party requests accesses from some resource protected by Airlock IAM, it requests some scopes. For example, this could be, I would like to access the email, the address, the balance, and the age. Then the user has to log in, and as part of the login, or usually after the login process, the user has to give a consent and grant some scopes. This is typically some kind of screen where the user can tell the system, well, okay, let them see my email address, my postal address, my balance. In this case, I don't want to give away my age. Then Airlock IAM, the authorization server, will issue some claims. This can be claims part of the ID token or in the user info endpoint and so on. And the claims can be actually anything. It can be bound to the scopes, or it can be not bound, or it can be independent on the scopes, but that's just the 3 steps that basically happen in a system. So what did we do in up to Airlock IAM 8.0? So what made us make things more flexible? So in 8.0 or up to 8.0, the scopes that are allowed to request, so they are defined per authorization server. So you could not define it differently for each client. It's just per authorization server. And also the claims, the issued claims are basically a fixed configured list. Of course, they can contain the scopes or not, but it was, for example, not possible to issue a claim based on the presence of a scope or on the presence of 2 scopes together. So this resulted in multiple definitions or configurations of authorization servers if you wanted to handle scopes and claims differently per client. So this in some cases made configurations really big and unhandy. So what did we do in 8.1? We added some new features. And first feature are scope policies. Now you can define on an authorization server level, you can define scope policies. The scope policy, it handles what is done with the requested scopes. Do we just take them as requested? Do we filter them? Do we discard them and use default scope and so on? Then you can define allowed scopes per client. So for all clients that are part of the configuration, you can define a list of scopes you want to allow or disallow. And on the claim issuing side, we introduced conditional claims. A conditional claim is a claim that is only issued if some condition holds. And one of the most important conditions is whether a scope is present or not. So for example, you can now implement the use case if the client requests scope email and the user grants scope email and it also is allowed for this client, then we can include the email address in the issued claims. Let's have a look a little bit more at the claims part. So claims are issued in several components of Airlock IAM. First of all, and most importantly, the token endpoint. In an OpenID Connect authorization code flow, the token endpoint issues ID token, which contains claims. There you can use the conditional claims now. Then you can also use it in the user info endpoint, and it is also part of the token exchange feature. So what does this mean? It makes it a lot more flexible. You don't have to configure multiple authorization servers. You can take full control of how to handle scopes and what claims to include in the tokens based on these scopes and based on other conditions. For example, this allows you also to protect single claims in a resource endpoint. So far, you could only protect the whole endpoint and not single claims in the resource endpoint. You can make single claims dependent on the presence of scopes in the resource endpoint. And you can also configure complex claim conditions using and or not or or conditions.
Thank you, Mark, for this interesting presentation. And I hope it will be interesting when we continue with integrating IAM with Microgateway 4. So as Mark did it before, I'll also introduce the topic first and basically saying what we did today. And today what we're proposing is that you use a classic zero trust architecture. You'll find in this architecture up here, we see end user devices, they connect to your network on the perimeter. We find an Airlock gateway, which will protect the perimeter. We have identity and access management, Airlock IAM here on the side that will be responsible for authenticating and providing authorization information. And down here, we'll find backend services, some unprotected, some protected with Airlock microgateways. That's the classic zero trust architecture. Now, we want to improve that classic zero trust architecture and focus more on doing everything with Microgateway because we find that our customers move to the cloud very rapidly, and having cloud native solutions for you is really at the core. And what I'm going to talk about today is how to protect Airlock IAM with an Airlock microgateway. Now, this is a journey in 8.1. We're taking the first few steps on this journey. It's not going to be complete. So when you install 8.1 and you use Airlock Microgateway 4, don't expect everything to work. But we're focusing on this particular connection and nothing else in the rest of the presentation. So with the explanation of what is changing and why this actually is quite a complex feature for us to implement, let me talk about how the classic Airlock gateway integration works. On the left-hand side, you see the client that connects through the gateway, and one of the things that we're doing with the traditional large gateway is we terminate the TLS session right here. We're inspecting the traffic, and if we agree that the traffic's okay, then we send it forward to the IAM. And we have an HTTP session, and the gateway provides IAM with env cookies. In those env cookies, we see basically the outside world that the gateway sees on the client side, and we can provide it to IAM. Now, why is it important that IAM actually knows about the outside world? Well, things like IP addresses, which are used in risk-based authentication, for example, to differentiate on whether someone is connecting from an internal network or from an external network, or entry URLs, which IAM requires to understand and needs to provide correct responses, to create redirect URLs that work. These things we need in IAM for IAM to work properly. The other thing that we have in between IAM and gateway is copy, the control API, where IAM can tell the gateway about authorization information by providing roles and particular mappings, so that a user, once he's authenticated, is actually also authorized to connect to a backend. Now, all of that is the old world that still continues to work. And now we're adding a new world that works entirely differently, because in Kubernetes and deployments, you're no longer working with env cookies, and you don't want proprietary protocols like the control API. So what we see here is that you have a client that somehow connects to a cluster, and already at the edge of the cluster, you have things like a load balancer, you have ingress controllers, you may have a service mesh using Istio. And all of these components are working in front of the pod where we're actually deploying the microgateway and your IAM. So we need to be able to integrate TLS termination on an ingress controller with the microgateway, and then forward information from the microgateway to IAM. And the way we do that is no longer with env cookies and control APIs, but with HTTP headers. And the focus during development of IAM 8.1 was on analyzing and integrating the microgateway IAM connection. So what are the features in the current versions? Well, we have headers that are interpreted by IAM 8.1, which is the IP address request ID. Of course, that's very important for logging. The entry URL, as I said, it's important so IAM can prepare correct redirects. And what we've also integrated are SSL certificates. One of the first features where we're using that information is context extractors. So you have context extractors that directly interpret HTTP parameters or that are based on the entry URL. So context switching inside configuration context inside IAM continue to work as you have come to know them in the past. To add the security aspects, we're also going to add Microgateway 4 features. And one of them is CRDs. Now, CRDs are basically the equivalent of deny rules in Microgateway or Envoy technology. We're adding CSRF protections, so cross-site request for forgery. And for client certificates, we're implementing FCC forwarding. All of these configurations will be provided in a minimal help chart, which will be published on GitHub. It may take us 1 or 2 weeks after the release of IAM 8.1 until they are available on GitHub, so stay posted. We will have the correct link in the documentation for you to find that information. So how do you use that? Well, the Microgateway configuration can be applied in the login app, in the admin app, and in transaction approval. And it's actually fairly straightforward. In the gateway settings, instead of just configuring the gateway settings themselves, you can now add 2 plugins, either a gateway settings plugin, which will contain all the traditional configuration for the large-scale gateway, or you can create a new plugin for the Airlock Microgateway settings. And inside the Microgateway settings, you're basically going to decide on how the 4 different headers will be extracted, what kind of plugins that you're going to use there. So this configuration is the only thing that changes, and you only have to apply that if you really want to protect IAM using a Microgateway. Another topic, FIDO. FIDO has been introduced already with IAM 7.4. Believe me, I've checked, it's already been here a long time. But we've always lacked the capability of actually allowing users to manage their own devices, and this is why we've added quite a bit of features. So end users in the login app now are able to list their FIDO devices, they can delete FIDO devices, they can rename them, and they can enable or disable them. As I already said here, a screenshot on how you can change the display name of a FIDO device. And of course, IAM, when you're using the login app UI, will use that display name in all the places. For example, in the security key management screen, of course, you can change the names here on this screen using the translation features in the design kit. You have a disable and enable button on this screen, so you can disable and enable different devices. You have the delete button. Of course, you can also prevent a user from deleting the last device from his list, and the user can add a new security key, or he can just leave the page. So in a nutshell, these 2 screens tell the entire story of what we implemented or added with regards to FIDO device management as self-services for the end user. The configuration of the feature is also fairly straightforward. If you're already familiar on how to configure protected self-services and the respective UI, then you probably will find it not very difficult to do so for the FIDO tokens. If you're not familiar, we've provided a documentation in the online documentation chapter FIDO token management self-service configuration, which will give you a step-by-step guide on how to set it up and how to make it work. Believe me, it's fairly simple. Even I was able to handle it and get it done. And now for something completely different. Self-sovereign identities, or SSI, aka decentralized identity. What is it? Well, self-sovereign identities is the term we normally use in Europe, whereas in the United States, they very often call it decentralized identity. is all about a new paradigm in identity and access management. And let me try to explain it a little bit on what it is about, and then we'll go on and see why this is important. The first thing is, at the core of SSI, we have the user. Well, we don't call him user, we call him holder, because he holds a wallet application. And the wallet application is really that. It's an app running on your smartphone, and it's supposed to replace your physical wallet where you store your credit cards, your memberships, your health insurance card, your identity card, your driver's license, and all these things. So we put that into the electronic realm, and as with all these cards, we also, in this particular setup, we also have an issuer of such credentials. And the issuer might be the state that provides you with an electronic ID or EID. Or you could have the motor vehicle department, Straßenverkehrsamt, that provides you with a verifiable credential that is your driver's license. What we also have is verifiers, those guys where you actually present those credentials. This could be a doctor where you're showing your health insurance card. It could be a policeman where you're showing your driver's license, or it could be a web shop that kind of wants to know where to send the goods to, and maybe you're using your resident permit to actually provide the web shop with that information instead of typing it in all yourself. So the holder is at the core, and the two roles, issuer that issue credential, verifier that obtain and verify credentials, this is kind of the most important part of that new paradigm. Now, why is it so important? Motivation. Nation states like Switzerland or the EU and all the member states are preparing national EID laws. And those laws will basically make the self-sovereign identity technology the basis on how we're going to interact and how we're going to exchange data. Now, Switzerland said they want to be done by middle of 2025. A few days ago, they announced that they're not going to make it and by early 26. The EU said they want to be done by middle of 24. The way they're progressing, I seriously doubt that they're going to meet their own goal, but we'll see. Nevertheless, both Switzerland and the EU, they're already in progress with a project. For example, in Switzerland, there is a public sandbox where quite a number of organizations are actually testing the technology and exchanging self-sovereign identities as issuers and verifiers. The EU, they have what they call large-scale pilots, and they really mean large-scale pilots because every single member state is in at least one pilot. Many member states are in many pilots. They have something like 280 organizations, which are private and public organizations working in these large-scale pilots. And from what I understand, the budget of the large-scale pilots is several hundred million euros. So they're really also spending quite a bit of money on the topic. So it can't be irrelevant to them. And why do they actually do that? Well, one of the reasons why it's so important is because privacy by design is already built in. If you remember the graphic I've shown before, a holder receives credentials from an issuer and presents them to a verifier. And it's always the holder's decision on whether he's going to present the credential or not. So there is no data privacy issue, or it's not possible to create a data privacy issue if the owner of the data, us, basically always has to decide that he's willing to share first name, last name, or address of residence with a verifier. If you're not willing to share it, then you don't do it, and data privacy is guaranteed. The second thing that is really interesting is that the technology provided here or proposed here not only works for people, but it also works for organizations and things. And actually, one of the large-scale pilots in the EU cares about IoT and really focuses on how to use the technology with things. And lastly, when you get data from a credential that has been issued by an issuer, that data is from an authoritative source. An EID has been issued by a national entity, and the national entity is basically the authority on your last name, first name, ABS 13 number, and other things. So if you get data like that, you don't have to verify it, and that makes registrations and enrollment processes very fast. No additional inspection required, and also very cheap because you can do them fully electronically, no video ident or auto ident required. So there's really some very strong driving forces behind it. Now, just a few screenshots to show you on how it actually works from an end user perspective. So when you're using SSI credentials, and this is how you get issued an SSI credential, then a website will present you with the QR code. And what you do with the QR code? Well, you scan it. And this time you don't scan it just with your camera, but there is an app on your mobile phone, the wallet app, that you use to scan this code. And it basically tells you, yep, do you want to connect there? Though this QR code contains enough information to establish a secure connection. If you agree, then it will offer you a credential, and you see here, I'm being offered a credential with first name Michael, last name Duyak, and an email mike@aragon.ch. And of course, I click accept, and once I accepted this, I now have in my wallet a credential that I can use to present to verifiers, and all it took me was I had to connect, I had to accept, and then it's there. So it's really quite easy and simple to use. It's fully integrated into the wallet, and there is actually enough test wallets for you to use. Now, I've said that we've included this in Airlock IAM 8.1, and the SSI package contents is quite extensive. We have plugins and business logic, of course. They expose a REST API, so if you want to use it with your own mobile clients, you can do that. We have, of course, as always, a UI in the login app, and in the design kit, you can also style it. We have documentation. It's rather limited, and if you're running really into problems with it, it's an incubating feature, so feel free to get in contact with us. We'll try to help you. And to make things even more simple, we omitted the license tag. It will appear in later versions of the feature, but right now you just can use it out of the box. There is no hindrance that you first have to ask us for a test or evaluation license. Beware. These SSI features in 8.1 are experimental, and we definitely know that they will change in future releases. So right now they're intended for proof of concept implementations, even though the programming and everything and the testing quality assurance has been done on the level that you would expect from regular production grade releases. They still are experimental, and since they will change in future releases, we cannot allow you to rely on them being unchanged. Now, looking a little bit further under the hood, let's talk about the SSI feature step or feature set. The first features we have, of course, most important ones probably from an identity and access management perspective is authentication. And we even have a passwordless authentication step where you basically just scan the QR code, you approve in the wallet, and you're logged in. Then we have the SSI issuance step. That's what I demonstrated before. And we have a verification step where we basically obtain information from a credential and can use it. Now, where you can use it? Well, of course, the authentication steps are in authentication flows. The issuance step can be used either during authentication, you'll directly issue a credential during the authentication, or you can provide a protected self-service. You can connect the protected self-service to a button on your website somewhere, and the flow will start and issue a credential. Verification, you can do that during authentication, but also in self-registration. So you can set up a flow where you're actually extracting information from a credential and use it to populate a newly registered user, or you can use it in a public self-service as a verification step, for example, in a password reset or in a self-unlock flow. A few words on the architecture. The most part, actually, you'll find that the architecture is quite similar to what you already know for Airlock IAM, there's really only 2 points that we need to look at a little bit. One is the wallet application, which is on the holder side. And if you want to deploy it with IAM, there is a new Docker container that you need to deploy, which is called Akapai, RES Cloud Agent. And this implements part of the SSI protocol and handles the communication with the wallet. So wallet app is new and the Akapai Docker container is new. Focusing in a little bit, the wallet app is on the smartphone of the user. Akapai is a Docker container, and Akapai also needs a small database. In the documentation, we provide you with a few simple Docker Compose scripts that will start the required containers. And we also have included in our setup, since we expect you to test this first on some development environment, we also have provided instructions on how to set up an ngrok tunnel so you can expose the Akapai endpoints on the outside world and test this in a real life setup just locally on your laptop. Good, that's it for self-sovereign identities, a new incubating feature with IAM 8.1. And now I'll hand back to Mark for a few various features.
Thank you, Mike. In the last few minutes, I'm going to tell you something about other various features, smaller features that we think are worth mentioning. For a full list of feature and bug fixes, please refer to the changelog in the documentation. So first about event notification features in 8.1. First thing is that events are now processed asynchronously. It means that if an event is thrown, the event handler is called in an asynchronous process or thread. This means that, for example, slow event handlers can no longer impact IAM performance. And it also means that if an event handler fails, for example, if an event handler tries to connect to another systems like a REST responder or an SMS gateway or an email gateway, it no longer negatively affects the IAM business requests. Please be aware that we didn't change the meaning of events or the guarantees we give. Events can still get lost, so that was as in 8.0 and before. Events can still get lost. We just try to handle events by calling the event handlers, and if they fail, events are lost. So there's no guarantee an event is really delivered, but this has not been changed since the last release. Then also we added new events. We added an event when a user is created. It doesn't matter how it is created. It can be in the login app, in the admin app, using the REST API or the UIs. It does not hold for the service container. So if you have, for example, a user sync task that synchronizes users from another database or from an Active Directory, it will not create user-created events. It just works for the login app and the admin app and the transaction approval module. Also, we added a user deleted event, which works similarly if the user is deleted. Then we added a new condition which can be used in all kinds of flows, which looks if a device, an authentication device or an authentication token has been used for the first time or not. Currently, it only works for Airlock 2FA tokens, but it might be extended to other tokens in the future. So with this new condition, you can now design your flows according to whether a device was used for the first time or not. To give you an example, you would maybe want to involve a password after enrollment with the first usage of a device, but not afterwards. Then we also made a change or an improvement regarding single sign-on tickets. So far, single sign-on tickets that have successfully been used have been consumed, so to say. They have been stored only in memory to prevent replay attacks, so to prevent that the single sign-on ticket can be used twice. This worked well in single instance setups, and it bared some risks in multi-instance setups. And now, if you like, you don't have to, you can store the SSO tickets that have been used in the database. So it really works correct across also active setups. This is really important if you intend to use multiple active IAM instances, or if you run IAM, for example, in Kubernetes, where you have a lot of IAM instances come and go. Then there's another small feature worth mentioning. There is a new value provider you can use in flows, which allows you to inject HTTP headers from the current request. So with that, you have the possibility to look, for example, in a condition at a value of an HTTP header, and then depending on this condition, you can, for example, take one way in a flow or another subway in a flow. This provides you with a lot of flexibility if you want to steer the flow, to direct the flow based on HTTP headers sent, for example, by a mobile application or a single page application. So to close this video, I would like to give you some general release information about Airlock IAM 8.1. First, how to upgrade to 8.1. So 8.1 is a non-breaking release. So the deal is, if you are not using new features, if you just rely on existing features, you don't have to do anything manually. You can just migrate the configuration using the automatic migration, and it should work as it was. If you're using new features, then you have to upgrade the database schema. So far, this is using the state externalization feature, the single sign-on ticket feature I just presented, and the first device usage condition I just presented. If you're using one of these features, you have to upgrade the database schema, and we recommend to update the database schema in any case anyway. So for the details how to upgrade, you could have a look in the manual in chapter 6.5, where it's about upgrading IAM. So what else? The release has been released in end of September 2023, and it will be supported until mid-2025. It's a minor release. As said, it's non-breaking with priority low. So we recommend to install the release if you either have to use a new feature, or if your prior release is about to get run out of support. The documentation can be found at the usual place and under docs.airlock.com, and also information on Academy you can find on www.airlock.com. The prior supported releases, they end, depending on what release you're using, pretty soon. 7.6 ends end of this year, 2023. 7.7 is supported until July next year, and 8.0 is supported until end of January 2025. So if you're still using 7.6, you really should upgrade pretty soon. And if you're still using 7.7, we recommend you to plan your update right now, because going from 7.7 to 8.0, it requires some changes, especially if you're still using the old login app, the JSP-based login app. The release date of the next release, it will be a minor release, 8.2. It's planned for end of March or beginning of April next year, 2024. As always, this is not really a fixed date, but it's what we plan to do. So thank you very much for watching this video. I hope it helped, and we are glad if we get some feedback. You can open a support ticket to give us some feedback or ask questions, and hope you enjoy IAM 8.1.